All right, let's dive into our weekly look at the semiconductor world. And this week, wow, there's really only one story. It's not just a trend, it's a full-on shockwave, and it's all being driven by the insane demand for artificial intelligence. So let's jump straight to the headline that kicked everything off.
For what feels like forever, the big story has always been about consumer tech, right? The iPhone. But what we're seeing here, this is the first major tremor from that AI shockwave. The center of gravity in tech has officially moved. It's no longer about what's in your pocket, it's about what's powering the data center. And get this, for the very first time, the AI giant NVIDIA is now the #1 customer for the most important chip foundry on the planet, TSMC.
So to really get our heads around how we got here and maybe where this is all going, we're going to break it all down. We'll look at the demand, then the global reaction, then we'll uncover a huge bottleneck, check out the tech being built to fix it, and wrap up with some of the big questions still hanging in the air.
Okay, first up, let's talk about what's driving all this. And it's not just growth, you guys. It's a straight-up explosion in demand for AI compute that's putting a strain on, well, pretty much every part of the industry. Just let this number sink in for a second. $215 billion. That's NVIDIA's new record for annual revenue. And it's almost all coming from the AI gold rush. I mean, to put it into perspective, think about what made NVIDIA a household name. Their gaming GPUs, right? That whole legendary business is now just a little over 11% of the revenue. Yeah, there's no doubt about it anymore. NVIDIA is an AI company, full stop.
And all that money, it translates directly into a need for manufacturing. This chart just lays it out perfectly. NVIDIA is now eating up over 19% of TSMC's total foundry capacity. They've officially kicked Apple off the top spot. And this isn't just some change in the sales rankings, folks. This is a fundamental rewiring of the entire semiconductor food chain.
And this demand? It's being backed by just staggering amounts of cash. We're talking OpenAI raising $110 billion. NVIDIA itself is throwing $30 billion of that in. And then you see this colossal $100 billion AI hardware deal between AMD and Meta. When you have that kind of money flooding in, it puts insane pressure on every single component, from the little power managing MOSFETs all the way up to the optical modules that let these servers talk to each other.
So, the big question is, how's the world supposed to deal with this demand shockwave? Well, it's kicking off a brand new geopolitical race for who can build the most chips, and it's literally remapping the global supply chain as we speak.
And right away, you can see two very different game plans taking shape. On one side, you got China going all in. I mean, they're reportedly aiming to boost their advanced 7 and 5 nanometer chip production by 5 times just to power their own AI ambitions. And then on the other side, you have the US, which is really pushing hard and fast to bring critical manufacturing back home, basically to lock down its own AI supply chain.
At the same time, other countries are trying to find their own angle. Japan, for instance, is rolling out the red carpet with these massive incentives. We're talking cutting the total cost of owning a new fab by over half compared to building in Korea. But, money isn't everything. Politics are getting in the way, making the Korean memory giants like Samsung and SK Hynix pretty nervous about committing. It's a huge potential roadblock.
And right in the middle of this whole storm is the current king, TSMC. And they are not sitting on their hands. Nope, they are doubling down, right at home in Taiwan, pushing their own expansion faster than ever. The reports are saying they've got up to 10 new fabs either being built or about to break ground. Incredible. But see, building all these fabs for logic chips, it creates a whole new problem. GPUs are only one piece of the puzzle. An AI engine is incredibly thirsty for memory, and that thirst is causing a massive bottleneck. It's kind of an unseen crisis that could actually bring this whole revolution to a screeching halt.
And this isn't just speculation. Industry leaders are actually putting a date on it. The CEO of Acer is now on record saying he expects this shortage to last well into the middle of 2026. And we're already seeing it happen. There are reports that Kioxia has already sold out its entire 2026 supply of NAND flash. That's the memory that these giant AI systems use for long-term storage. It's just gone.
Now, a shortage like this, it's got to have a winner, right? And it does. Samsung. The memory giant saw its DRAM revenue jump by a whopping 40% in just the last quarter of 2025. And that was enough for it to snatch back its crown as the leader in that market. Now here's the really crucial part. Samsung isn't just riding the memory wave. It's using this dominance as part of a much bigger comeback plan. They're calling it the Great Reversal. The idea is to use their lead in next-gen HBM4 memory while at the same time making huge progress in their 2-nanometer foundry business, where hearing yields are hitting 60 to 70%. They are closing that tech gap with TSMC, and they're doing it fast.
Look, you can't solve a problem this big just by building more factories. It's going to take some serious fundamental breakthroughs in the actual tools and techniques we use to make chips in the first place.
50%. That's the boost in chip output that ASML is aiming for by 2030. Now remember, they're the only ones who make the supercritical EUV machines. So this is a huge goal, and it's aimed squarely at one thing: helping ease these supply shortages by making every single machine they sell that much more productive.
And the key piece of tech that makes this possible is called high nano EUV. The simplest way to think about it is like having a much sharper knife to carve the circuits on a chip. It is absolutely essential if you want to manufacture it 2 nanometers and smaller. And just this week, IBM showed that their process is working, proving that the tech is on track and ready for the next generation of bleeding-edge chips.
And, it's not just about printing smaller and smaller transistors anymore. It's about how you put them all together. We are deep in an advanced packaging race. You've got technologies like hybrid bonding, which basically stacks chips right on top of each other to move data faster. That's becoming critical for these AI superchips. And at the very same time, companies are exploring panel-level packaging to get away from round wafers, which could totally change the economics with a massive increase in output.
Okay, so for our last section, let's just pull the camera back a bit. Let's look at some of the deeper challenges and the ripple effects that are going to define what comes next in this whole AI-driven era. So the road ahead, it's definitely not going to be easy. As we solve one set of problems, brand new ones pop up. For example, a huge new challenge is figuring out how to deliver power from the back of the chip without everything melting. And in this really interesting twist, the demand for AI is so huge that it's actually causing a comeback for older 8-inch wafers. All of this is happening while big players like MediaTek start to design their own custom AI chips for the cloud. The game is constantly changing.
Which leaves us with a pretty provocative final thought. The AI revolution is absolutely here, and it's all being built on silicon. But with the supply chain stretched to its absolute breaking point, it brings up a really fundamental question. In this massive, high-stakes race, who's actually going to end up in control of the foundational technology of the 21st century? Is it going to be the innovators with the best tech, the investors with the deepest pockets, or the nations with the strongest political will?